Welcome. In this video we are going to learn exploiting the module structure in Metasploit. It is very essential to understand the exploit module structure as it will help us in proper analysis of different exploit modules. As the Metasploit framework is an open source project, its development depends on the contribution from the community. Developers from around the globe convert proof of concept of various exploits into the Metasploit module so that it can be used by everyone. Hence, you can also contribute to the community by converting newly discovered exploit into modules. Also, there may be a situation where you need a particular exploit which is not in the framework. Knowledge about the exploit module structure will help you in easily converting the exploit into a module. In this video, we will get to know about the basic structure of a module. Let us start by understanding the modular structure of exploit within the framework. It is similar to an auxiliary structure with some specific fields. You can find the exploit modules in the pentest/exploits framework 3 directory. Let us analyze the structure of exploit in MSF. Let us see how we actually do it. As I discussed in previous video, the format of an exploit module is similar to that of an auxiliary one with some specific addition. Type require MSF/core. Type class Metasploit 3 less than MSF exploit remote. Type rank equals to excellent ranking. Include MSF exploit remote TCP. Include MSF exploit exe. The module starts with including the MSF core libraries into the script along with declaration of a class which extends the properties relevant to the exploit. In this example, the Metasploit 3 class extends the remote exploit libraries. In addition, the script includes other libraries such as TCP. Type define space initialize info equals to flower presses. Type super update info. Type name equals to greater than, just quotation, keep it blank. Type description. Then we have the initialize function that is used to analyze the different values and content definition of the modules. Some of the primary definition of this function include name, description, author, version, and so on. That is register_options, opt, rport, 777, self.class, and. Next, we have the register option part of the script, which is responsible for providing essential and default values of the script. The values can be changed according to users' needs as well. It has been very similar to auxiliary modules. The difference lies in defining the exploit function. Type def space exploit. Type connect. Type sock.put payload.encoded. Type handler. Type disconnect. Type end. This is the main exploit body of the module that contains the shell code or the exploit pattern. The content of this function varies from exploit to exploit. Some of the key features that may exist in a remote exploit are listed in the body of the function. The connect function is used to open a remote connection with the target. It is a function defined in the remote TCP library. A payload is also an essential part of the exploit body, which helps in setting up back connections. We can also define handlers in the exploit body depending on the need. Optionally, you can also declare a vulnerability test function, check, which verifies whether the target is vulnerable or not. It verifies for all options except the payload. This was basic introduction to modules of Metasploit. In later on part of the course, we'll discuss some core concepts related to the exploits in the framework. So that's all in this video. Thank you for watching this video.